Good day, ladies and gentlemen, boys and girls, and friends and neighbors. I come to you today with a little bit of discussion about Unit 9, Lesson 1, continuing our discussion about trigonometry, specifically sine and cosine functions. Today we're going to talk about the inverse of sine and cosine functions. I think today we're just going to get to the inverse of sine. Tomorrow we'll talk about the activity, Unit 9, Lesson 1 activity that deals with the inverse of cosine. So what I'd like to start with today, and before I start, I would like to mention that keep in mind this is a video. I'm going to try to limit the video to about 15 to 20 minutes. So it may seem like I'm rushing, but know that when you're watching this video, you will have a pause button. You can actually have a rewind button. So if you need to pause or rewind, please do so. Okay, so today we're going to be talking about, like I said, inverse of sine. Before we do that, we're going to talk about if this whole section here was copy and pasted from our discussion of one-to-one functions back in Unit 5. I think it was Unit 5 that we did this. And here's what we said about one-to-one functions. If a horizontal line intersects the graph of a function at one and only one point, the function is one-to-one. If a function is continuous and always increasing or always decreasing, then f of x is one-to-one. Always increasing or always decreasing. It cannot be both increasing, decreasing. If it was, then this horizontal line would intersect the graph at more than one point. And here's the key point right here. If a function is one-to-one, these are the two things that tell us if it's one-to-one. If a function is one-to-one, then that daggone function has an inverse function. Here is big. The next two bullets are going to be very, very big in today's discussion. And they are big in the discussion of any inverse functions. The domain of the inverse is the range of the original. The range of the inverse, is the domain of the original. In essence, if I have a particular function, f of x, and a comma b is on that f of x, and f of x does indeed have an inverse, call it whatever, call it inverse of f of x, then what do I know? BA is on that inverse. The domain becomes the range, and the range becomes the domain. Very, very, very important today. So let's see here, and we know and we recall that if a function is one-to-one, then we denote the inverse of f inverse, and that's how we read that. And we want to note that this is f inverse does not equal 1 over f of x. So let's get back to our discussion of trigonometry here and look at this function sine of x. We know, and we graph sine of x, all of us were able to graph sine of x quite nicely. And we know that, whoopsie, let's see, I want to grab that guy right there. I want to grab that horizontal line. We know, all of us did this very well, that the sine graph starts 0, goes min, 0, min, goes max, 0 max, 0 min, 0 max, 0 min, 0 max, and goes infinitely. And it goes in these, if I go to the negative x's, same thing. Min, 0, max, 0, min. So, if that's the case, and it is indeed the case for the graph of sine of x, if I grab this horizontal line, if I can actually grab that horizontal line, not the whole daggone thing, there it is. If I grab that there's no way on earth that sine can have an inverse. Well, if sine cannot have an inverse, then why can I look at my calculator, as we're going to see tonight on some of the IXLs, is there this button on the calculator? And that's what we're going to talk about, because there is indeed an inverse sine. So we're going to create this inverse sine. So let's go, here we go. Okay, Clearly, sine of x is not a one-to-one function since horizontal lines could intersect the graph infinitely many times, as I just demonstrated. The graph increases, increases, decreases, decreases, increases, decreases, increases. Okay? What we're going to do is we're going to restrict the domain of the sine function where it's only increasing or only decreasing. And the first interval that we're going to restrict it to is this guy right here. -3, whoa, -3 pi over 2 to -pi over 2, like this guy right here. I wonder if I can grab this. Yeah, there. Oh, nicely done, Lee. Okay, so look, and the yellow is the graph of the entire sine graph. But if I restrict the domain from -3 pi over 2 to pi over 2, my graph is only decreasing. Ooh, then a horizontal line would cross it only once, and I could be talking about the inverse. Or you know what? I don't want to restrict it over here. I want to restrict it over here to 3 pi over 2 to 5 pi over 2. Oh, again, I have a domain. I have the domain that allows the sine only to be increasing. And if you think about this, there are multiple intervals that I could restrict the domain of. I could have gone from here. There's multiple domains. So what we need to do is we need to come up with a general consensus for the students at Madison or the students at Northern Indiana or the students at Southern Australia so that we can all be talking about the same inverse sine. And that's exactly what the mathematicians did. They said, hey, here we go. We are going to take in any elementary trigonometry class, this is going to change when you get into advanced trigonometry classes. You can restrict the domain wherever you want. But what we're going to do in our elementary trigonometry classes is we're going to restrict our domain to -pi over 2 to pi over 2, this rascal right here. And we're only going to look at the graph right there. Why? Because that's just what the mathematicians decided. We're going to use this guy right here. We're going to use this particular domain right there. Why? Because that's what the mathematicians, all the mathematicians have decided would be a nice restriction to the domain and give us a nice portion of the sine graph to talk about. So here's our restricted domain of our new sine function. And this is a new sine function. Keep in mind, some books even denote this new sine function and they capitalize sin. And say, hey, we have a special. We're not going to do that. We're just going to say, hey, we're going to restrict the domain to -pi over 2 to pi over 2. Hey, what's going to be the range? The range is going to be the same thing from -1 to 1. So the range is absolutely the same. We're still going from -1 to 1. The outputs are still going to be going from -1 to 1. So if I label these 2 points here, and we're going to see those in a little bit, I have that point right there, which is -pi over 2, -1, and pi over 2, 1. And just think about this picture. So here's some very nice important points on the graph of the sine with this restricted domain. I have -pi over 2, -1, that point right there. -pi over 3, -square root of 3 over 2, -pi. Ooh, where did these points come? Where did these come? They came directly off of a portion of the unit circle, which I have sketched here. And I'm not going to label all these points. And if you want to pause the video, go ahead. And you can look about where these points came from. And if I look, because my domain goes from -pi over 2 to pi over 2 on the unit circle. I'm going, here's my restricted domain from -pi over 2 to pi over 2. And what are the outputs of these? These are the y values on the unit circle associated with all of these angles. -pi over 6, -pi over 4, -pi over 3, -pi over 2, 0, pi over 6, pi over 4, pi over 3, and pi over 2. That's where those values come from. And these are the important points. Now, since we've restricted the domain, we can talk about the inverse of sine of x. And we're going to call that, to keep down the confusion, we could very well call it this guy right here, and we could label it f inverse, but we're just going to make it easy for us, we're just going to call it g of x. We're going to let g of x be the inverse of sine, where sine has this restricted domain up here, and I'm going to denote the restricted domain. Okay. So what do I want to do? The first thing I want to do is I want to find the domain of my inverse of sine. How do I get the domain of the inverse is the range of the original. So what's the range up here? Oh, the range of the original is from -1 to 1. So that's going to become the domain of my inverse. Whoop, whoop. How do you get the range? How do you get the range of the inverse? The range of the inverse, where do we get that? That's going to be the domain of the original. The range of the inverse is the domain of the original. So what is the range of the inverse of -pi/2? And when I use my graphing calculator to find the inverse of a particular value, the output of the inverse of sine is always going to be between -pi/2 and pi/2. Interesting. And you're going to have to realize that. And we're going to talk more about that in the next couple days. And now what we want to do, and we know this, domain becomes the range. What we're going to do is name important points on g of x. Oh my goodness gracious. Well, you know how to do this. And when we did this, all of you did this quite well. And I'm not going to go through this. What I'm going to do is just come up with some nice points. A, B, B becomes A. And I'm going to go dot, dot, dot. If you want to write these inverse points, you go right ahead. Oh, I'll put that point in there. 0, 0. 0x becomes 0y, dot, 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 and then dot, dot, dot. And then I'm going to go 1, comma, pi/2. I'm at 12 minutes now. I'm going to try to limit this thing pretty quick. Now what I'm going to do is I'm going to try to give a rough sketch of the inverse. Ooh, ooh, ooh. So I'm going to use these points and use the fact that the inverse is going to be continuous between -1 and 1. And I'm going to estimate the value of -pi/2. And if I estimate the value of -pi/2, it's going to be about -1.6. I'm just going to use that as an estimation for my graph. I know this point, 0, 0, and this point is going to be 1, 1.6. About, these are abouts. So now if I graph that, this point here is going to be -1, -1.6. Keep in mind the y is about that. I'm a little bit below -1, and I'm a little bit above 1. This point right here is 1, 1.6. And this is the graph of the inverse of sine of x. Right here it is. Let's see here. Right here is the graph of the inverse of sine of x. Bam. And recall, and this is going to be, some of us are going to want to do this. Recall, the following discussion is for those of you that are going to be taking Calculus 2 next year, because keep in mind, the graph of the inverse is the reflection of the original about the line y equals x. So if I come over here and sketch the line, what color do you want to sketch it in? Oh, let's sketch it in this crazy, let's sketch it in this crazy orange color. And if I sketch this line y equals x, let me try to, and this is going to be kind of hard to do. One of the things that we're going to find next year in Calculus 2, and it looks like there's a gap here, but if I'm between -pi/2 and pi/2, there's going to be little difference between the graph of sine and the graph of y equals x. There just really is. And I don't even want to go about telling you what we call this line y equals x with respect to the graph of sine of x, but it's very important. And if I were going to reflect that, keep in mind it's so close, and put it on the same graph, that's going to be hard to do and hard to see. I know if I come down here, it's going to be, has an output of about 1.6. The top point, it's going to have an input of 1. So this is about 1.6. So it's going to come over here. I'm going to do this guy in black. It's going to come 0. And the same thing here. It's going to be about here. And it's going to look like this. Really, really hard to see on the same graph, sine and the inverse sine. And no one's ever going to ask you to do that, but I just want you to realize that, yes, indeed, this inverse is a reflection of the original about the line y equals x, but they're so close to the line y equals x, if you did this with a graphing calculator, you cannot tell the difference. So let's see if that's, I really don't think, I'm about 16 minutes on this video. So what I'm going to do, let's see what the next page. The next page is this activity 1. I'm going to have a video over activity 1 tomorrow. I will have an IXL that talks about the inverse. It's more about using the calculator to find the inverse of a particular value, or to solve a right triangle by using the inverse to find the angle measure. That's the one point. What are the endpoints? Let's do one more thing before we close. If I come back here and think about this domain, what are these guys right here? What kind of creatures is the domain of sine? These are angle measures. These are angle measures, and we know that. Angle measures given in radians. And these are just real numbers. The outputs are real numbers. So let's hear. The domain are angle measures. The domain, if that's the case, then the range of the inverse is angle measures as well. And that you're going to need to know on the IXL. This is a very important discussion we had today. You might have to re-watch this video a couple times. I will go over the activity tomorrow. So have a great day. I will see you soon. Keep up the good work.